Test 1, atomic structure. First question, state the block in which tungsten is found. It's found in the D block. State the number of protons and neutrons found in 184W. Look on the periodic table, and the number of protons is 74. Neutrons is 184, mass number, to take away the proton number gives you the number of neutrons, 110. Part B, give 2 reasons why the sample must be ionized. Select 2 of the 3 answers. The first answer, so that the ions can be accelerated to the negative electric field plates. Keyword, accelerate. Second option of 3, can be deflected by the magnetic field. The third option, ions accept electrons to cause a current in the detector so that they can be detected. State what can be adjusted in the mass spectrometer to enable ions formed by the different isotopes to be directed onto the detector. It's all about changing the strength of the magnetic field. Part C. State and explain the difference, if any, between the chemical properties of the isotopes 182W and 186W. Like all isotopes of the same element, there is no chemical difference because the isotopes have the same number of electrons and the same arrangement of electrons, and that is what's important with chemical reactivity. Part D. You've got to calculate the relative atomic mass of the sample of tungsten. You use the formula RAM equals the sum of the abundance multiplied by the mass over charge divided by the total of abundance. So 26.4 times 182 plus 14.3 times 183 plus 30.7 times 184 plus 28.6 times 186, all in brackets, divided by 100, because that's the total of the relative abundance, equals 183.90 to 2 decimal place as asked. Next question, a number of ways of stating this. Define the term relative atomic mass of an element. Look in your notes, whatever your teacher has used. The average mass of an atom of an element relative to 1/12 the mass of a carbon-12 atom. 2a, write the complete electron configuration for calcium Ca2+. Ca2+ means it's lost 2 electrons. So therefore its 4s2 electrons have been lost. So it's 1s2, 2s2, 2p6, 3s2, 3p6. Write an equation including state symbols to represent the process for which the energy changes the second ionization energy of calcium. Ca2+ goes to Ca plus goes to Ca2+, plus an electron, showing your G symbols. This is the second ionization as the 2+ charge is created. The ordinal here gives the charge. Define the term second ionization energy. Energy changed to remove 1 electron from 1 mole of 1+ ions to form 1 mole of 2+ ions in the gaseous state, which is an essential term. Explain why the second ionization energy of potassium is greater than the second ionization energy of calcium. Potassium's electrons, we've now gone inner shell. Calcium's outer electron is still on the outer shell. So potassium's second electron is being removed from a good term to use here is lower energy level. Lower energy level means in a shell close to the nucleus. So we're now on the 3rd shell here for K, the 4th shell here for calcium plus. The reasons the second electron is closer to the nucleus in K. Harder to remove an electron, greater energy. There is less shielding in K+, as there are fewer inner shells of electrons, 2 for K+, 3 for calcium+. Part 4, an element X in period 3 of the periodic table has the following successive ionisation energies. Deduce the identity of the element. What you need to do is estimate, or you can calculate, in fact, the steps, the jumps between these energy values. 790 between 1 and 2, 1655 between 2 and 3, 1123 between the third and fourth electron removed. There is then a massive jump between the fourth and the fifth electron removed. So that means that there are 4 electrons in a little group, a little cluster of electrons. They're on the outer shell. When we go in a shell, we get this massive value. We've gone in. This has happened because we've gone in a shell. It's closer to the nucleus. So it's a group 4 element, and the answer is silicon. Next, 3a, state and explain the general trend in ionisation energies across period 3. Period 3, sodium to argon. Increasing first ionisation energy as you go across the period. The point's nuclear charge increases, or the proton number increases. The shielding stays the same as you go across the period. All electrons are added to the same level. That's level 3. Another factor you could include, the atomic radius decreases as you go across the period. 3b, identify the element that has the highest second ionisation energy in period 3. Explain your choice and write an equation including state symbols that represents this ionisation energy. The answer is sodium. It's sodium because the second electron removed from sodium is on the inner shell. It's now on the second shell of electrons, the second level of electrons, which means it's close to the nucleus. There's less shielding. The equation for this change, to form a 2+ ion, Na plus gas goes to Na2+ gas plus an electron. And finally, number 4, element X has a relative atomic mass of 54.9. Identify the block to which the element X belongs. Well, 54.9 is manganese. That means it's in the D block. Give the electric configuration of manganese. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Calculate the number of neutrons. The mass number is 54. We've told that in the question. Of this particular isotope, 25 is the atomic number. 54 take 25 equals 29.